Today I'm gonna tell you about the progress made by the NeoSPCC team in the past 2 months, that is December 2022 and the January 2023. We'll start with NeoGo.
We've made 3 releases of NeoGo, starting with version 0.100.0, and it's an important one, not just because it has a nice number, but also because it completely supports all of the protocol changes that were made in the C# node version 3.5.0. So you can use it for current testnet and mainnet that were upgraded in December. It has some NeoGo specific changes as well. One of them is that we have removed some deprecated compatibility functionality with the old versions. You probably won't notice it, but you should be aware of it. So we also have changed our configuration files a bit. Old configurations are still supported, but we recommend that you take a look at the changes that were made and adjust your configs files, probably by just taking our samples for mainnet and testnet, because in some future release, maybe in half a year from now, we'll be removing support for these old ways to configure the node, like this field or this field and anything like. The configuration changes are rather simple. We have some settings moved from one place to another, and most feasible probably is that we can have multiple addresses for all of the services, and basically everywhere addresses are used. This changed syntax somewhat, but this at the same time gives you some new abilities, so we think it's gonna be good. Another change that I wanted to highlight in this release is that our compiler can now extract additional type data that can then be used by the RPC bindings generator to generate contract-specific RPC code that includes support for complex data structures. You can take a look at the example of how it works. So we've got a contract like this, and it's a pretty simple stub, but the most interesting thing about it is that it accepts a pointer to structure and also returns a pointer to structure, and the structure can be seen here. It's a needlessly complex one, but it's just to showcase what we can do. This contract also has a config, as all contracts in Go have. It's also a pretty simple one, so we declare this method as a safe one because it doesn't change any state. It basically does nothing, but anyway. So we can compile it in a regular NeoGo way. So it looks like this. The struct with the config file. We will output the nef file first to somewhere, and then the manifest also. That's the regular compilation string for NeoGo. So if we were to do that, we can take a look at the resulting manifest and easily see the problem with it. It has the method we want to return, but this method only has array types declared for parameters and return type, so this structure that we had above is totally missing. Now we can add an additional parameter to the compiler string to generate bindings data, and it looks like this. And we can also take a look at what's inside of this file. So this is an additional data, and it has a representation of this internal structure that we have in the smart contract. This file can be consumed by the RPC binding generator that will look like this. Generate RPC, and we can take a look at how it works. It takes manifest for the input, so we'll take it from here. It also takes this configuration file that was mentioned earlier. It's going to like this. And it also needs a hash of the contract. We'll just take this stub and let's output it to some file like this. So now let's take a look at what do we have inside. And it looks like this. And what we have here is this representation of the same structure that can be used by the backend code. And actually this wrapper that represents the contract interface, it has this struct method that accepts a structure that we have seen above and also returns it. So what it does is it calls the contract via RPC and then takes the resulting stick item and converts it to this new type. It does it with this function that looks pretty weird probably and complex, but that's what we have to do to get all the data we need. And the main thing probably is that this code is auto-generated, so you have to do nothing. All you really care about is that you have this structure and you have this contract reader interface that you can use on the back end, and that's it. What I've seen works for Go contracts, but we think the same functionality can be made for any other languages and SDKs, so we have submitted a proposal for a new ABI standard that can replace NEP14 and that will include this data that we currently have as an additional YAML file in NeoGo, but this will just be a part of the manifest JSON. So we have received some comments on it, but at the same time I can probably ask for anyone that have not yet looked at it to have a look and maybe provide some feedback, because there are some questions that can be improved, and we think that this standard is an important one. We don't change manifest formats often, and it's one of the core things of the Neo protocol, so please have a look and leave your feedback. The more we have it, the better we can make this standard be. Now let's get back to NeoGo releases. That's what we had for 0.100.0, but it was quite some time ago, and we had 2 more releases since then. One is a little update that probably is not very interesting for a regular public, but it was an important one for the NeoFS mainnet maintenance and upgrade, so we just had to do that. And the next one, which is also the most recent one, is a bug fix release. We have fixed some things that we have found and that were reported to us, so we recommend everyone upgrading to this version. That will require a resynchronization, unfortunately, but at the same time that's the latest and greatest version of NeoGo that currently exists.
What we are working on right now is fixing dBFT problem known as the liveness lock. It's a very rare and very specific case, but when it happens, it can stop the whole consensus process and break the blockchain. We can't let it happen to Neo, we can't let it happen to NeoFS, so that's why we're working on it.
What we have already done here is that we have created a TLE plus model for dBFT 2.0, and it actually pretty quickly finds this liveness lock problem, so we think it works. And we have also tried to fix the model, and it was an interesting experience in that some of our attempts actually reintroduced sporks, the dBFT 1.0 problem. But as of now, we think we have a model that works well enough, and TLE Plus is not able to find any misbehavior for it. This model doesn't have any liveness lock, and it works. At the same time, of course, it's not an easy thing, and this model needs to be checked once and again, and we need to try implementing it and then try to really test it. So this will take us some time to get some final result, but at least the thing that we have now already is promising. Another thing that we are planning to do in the nearest future is implementing the changes for RPC error codes as they are outlined in this proposal. It was submitted earlier last year, and we think it's in a good shape. It doesn't require any changes, so it can be implemented right away, and that's what we are going to do in NeoGo, and we hope that C# node will follow, because this makes interaction with RPC more reliable and predictable for the apps, so it's good.
Moving on to NeoFS. In the end of December last year, we have updated NeoFS mainnet to version 0.34.0, and it was previously updated to version 0.28.1 somewhere like in May last year. So we had a number of releases since then, and we have fixed a lot of bugs since then, and we knew of a lot of issues with this old version, but this update was long postponed for various reasons. Now it's done, and we have an up-to-date version of NeoFS running on mainnet. That's good.
But around the same time when we were finishing NeoFS mainnet upgrade, a new release was committed, and that's 0.35.0. It was actually ready late December last year, but due to operational issues, the relevant tag and the binaries were pushed to GitHub just last week. It's mostly about bug fixing, and we have fixed tons of bugs in various components. It improves reliability and handles disk errors better, and it also updates some of the dependencies like NeoGo, so overall it's a nice release.
What we are doing with NeoFS today we call a structural simplification. Internally, NeoFS has a number of components and services that are interconnected with each other, and by the way, they're using a number of protocols to do that, and they are also interdependent on each other. This makes it hard to deploy the system and makes it especially painful to maintain, operate, and update it, which limits our ability to deliver fixes and updates to the users. This is just not the way it should be, so that's why this problem is our top priority for now, and we're working on it.
So what we have started with already, and where we have some progress, is merging NeoGo consensus node and NeoFS inner ring nodes. If you are to take a look at the typical picture of the NeoFS structure, it has these consensus nodes that are NeoGo, some blockchain nodes. We also have RPC nodes for blockchain, and we have NeoFS inner ring nodes and storage nodes as well, because someone has to store the data. They are all interconnected, but they are using P2P Neo protocol, and they are using RPC protocol, and they are using gRPC protocol. And we have alphabet nodes, so-called alphabet nodes, that are inner ring nodes, that are closely tied with consensus nodes that run the blockchain, but they are currently different services with different configurations, different ports, and they have to be connected to each other to work correctly. At the same time, they use the same key, and we deploy them to the same nodes usually, so having them as two separate services doesn't bring any benefit, and we have decided to merge them. This will bring us to an alternative picture that will look like this, and we will have these consensus nodes and IR nodes merged into one service. They will no longer need to be connected with each other, and technically this picture can then be simplified by removing these RPC nodes, because inner ring nodes also can run RPC, and maybe even by replacing these links that are NeoRPC links with gRPC links, or the other way around. That's something that we will discuss and think about somewhere in the future, but for now we already have a prototype of this merged node, and it's quite promising. But that's not the only thing we have in our queue. We also want to integrate NeoFS contracts into inner ring nodes. NeoFS contracts are contracts that are deployed to blockchain, but they actually store NeoFS state data, and currently they are managed and deployed somewhat separately from this system, and it's a problematic relationship that we want to improve. But that's not the only thing we're doing with contracts. We are also reviewing them, auditing them for some things that we have found already, like some API limitations that we want to solve so that they won't be limiting NeoFS. We also want to drop some old code, starting with the so-called notary-less mode support that we no longer need. This will affect contracts, of course, and the node itself, and we expect to remove some substantial amount of code there. That will, of course, simplify our future developments, because we will no longer need to think about this mode and test for it.
The next thing on our NeoFS to-do list is SDK 1.0. We know third-party developers need some stable version to be able to do their cool D apps, and we don't want to block them. We want them to be building on top of NeoFS and doing all the things they want with NeoFS. So we will get to it once we're done with the things mentioned previously, and we'll be working on it.
And the last thing I wanted to mention today is that we have previously done some work for the Neo name service. We know it's running on mainnet now, and you can get some names, you can get some neo.link domains. But if you're interested in hosting real domains like example.com on Neo name service, you should check out these pull requests. They make NNS work a little more like real DNS and actually allow to bridge DNS and NNS with the core DNS plugin. So if you're interested in that, check it out.